help us provide a more holistic view of the art. Now we choose image and text modalities because those were the most common attributes that were associated with art. Most of them have some title associated with the piece. Now, the problem that we're tackling is that art can lie on both extremes. It can either be very expressive or very abstract. Now, the we believe that it doesn't just rely on what's depicted, but it's also reliable on the color, the texture, the style. Now, just to summarize the related works in the domain, detection of sentiment and emotions have already been around, but we have seen that such analysis on art has not been much elaborated. Now, the WikiArt's emotions dataset that we use is actually fairly new. It was just released a couple of years back, I believe, and it also has not been studied enough. And unimodal classifiers, of course, perform really well, but multiple modalities have been very useful in the past literature. To the best of our knowledge, ArtNet is actually the first model to use multiple modalities to classify art pieces based on the emotion. To summarize our data set, the WikiArt's emotion data set is actually a subset of the larger WikiArt project. The WikiArt project classified the art pieces into style categories, and the WikiArt's emotion datasets took some images, about 200 or so, from each category and then annotated them with emotions. The annotators were actually provided with three scenarios: one to depict just the emotions by the title, one for just the image, and one for both. Now, we made a data-driven decision to club all the labels which had less than 200 frequency. That was because a lot of the categories just has about one or two data examples in a set of about 4,000. Coming to the model, we have, so firstly, we'll describe the individual models, the single modality models. For our text model, we take just a bi-LSTM and an attention add an attention mechanism. And the resultant vectors go for both the early fusion and the straightaway predictor. And for the image, we put the image through a pre-trained ResNet, which then goes through an attention mechanism followed by concatenation, and similar to text, it goes through the early fusion and the predictor. Coming to the fusion model, we take both the image and the text representations and concatenate them, followed by just predicting on the raw vector. We then look at the effect that ensembling these predictors have. We have three setups for the ensemble. One which is just the individually optimized models having a soft coding mechanism, one being an end-to-end trained vanilla model, and one being one of the state-of-the-art parameter shared end-to-end model, where the training is done in a very optimized, in a shared representation fashion. So looking at our results, we see that the fusion model performs better than the individual model. This proves our hypothesis that unimodal models may not be as effective in such a domain. Coming to the ensemble models, we see that the individual models surprisingly performed the best out of the three. This may be because of the abstractness of our dataset and how learning such a complex task may involve more careful hyperparameter tuning when seeing such a large and complex models like neural networks. Now, just as a look at our qualitative results, we can see in the first photo that the ensemble and the fusion actually predict the correct emotion, while the other two modalities actually can't. While in the second photo, we can see the title, which is Chalice. Now, Chalice itself doesn't betray the emotion that the image may evoke, but the image does help with the true label. Similarly, we have the other two photos with the text modality, and finally, none of them predicting it right, the fusion predicting it right again. To conclude, we present this classification model that can predict the emotions evoked in a viewer for art. And we believe this can be used for this has quite a lot of applications. It can be used to expand a data set further. Now, having a large data set with emotions evoked as our annotations could help us style transfer models like GANs. Imagine something like creating art out of nothing, which can evoke a certain emotion. We also believe that unsupervised learning methods can be used to overcome the challenges that the limited dataset presents, and we could use a larger WikiArts dataset to further improve art and net. Also, we understand that our data-driven decision of clubbing classes together may prove to be a detriment, and hierarchical classification would help us overcome that. I believe that would be. Thank you. I would be happy to take any questions.
Yeah. So, anybody there with a question for Mihir?
Hello.
Yeah.
Can you explain more details about your model? So you introduce your model is end-to-end architecture. So can you show the slide of the model?
This one?
Yes.
Yeah.
So how to assemble the data in 3 setups?
I didn't get that. Sorry. Could you please repeat that?
Okay. So what I mean is about how you predict the results.
Right.
What kind of soft voting? What do you mean, the soft voting?
So what we do is we take three predictors: the image, the fusion predictor, and the text predictor, and all of these output a certain probability with each class. So we take the average of all those probabilities and look at the max of the probabilities. So that represents our predicted class. So if I could expand on that if that doesn't answer your question.
Okay.
Should I give an example maybe?
Yes.
Sure. So let's assume that we have two classes, and the image predictor says that the first class has a probability of being 0.8 as a true class, and the early fusion one says that it has just a probability of, let's say, 0.2, and the text one says 0.6. So we'll take the total three probabilities and calculate the average, which would be around, I guess, 0.533, and that would be the probability of the art piece being related to the class 1. Similarly, we'll be calculating the probabilities for the second class, and we'll see which of them is higher. That will be a predicted class as well as the predicted probability.
Okay, thank you.
Thank you.
So we have time for one more question to Mihir. Is there any other question? Okay. In that case, we can move on to the next paper. Thank you, Mihir. So the next paper is, is Himanshu ready with his presentation?
Yeah, I think Himanshu is ready. So Himanshu, I'm making you one of the as a presenter. You can share your screen. So I made you the presenter.
So the title of this is Book 8, Designing a Venue Booking System. Yeah, go ahead, Himanshu.
Himanshu, can you hear us? Himanshu?
He's there, but
Himanshu, can you hear us? Okay, well.
Okay. And should we go on to the next one?
Yeah, probably.
Okay, so is there Mohit, Varun there who can present the paper on development and evaluation of an AI system?
Okay, Varun, I'm making you as a presenter. Can you try sharing your screen? Varun, can you hear me?
Just a minute, I'm doing so.
Okay, good.
Rajiv, I see that. No, okay, fine.
Yes, my screen is visible.
Yeah, Varun, we can see your screen. Could you please share your
Yes, yes.
presentation?
Okay, okay.
Okay,
Uh,
thanks. Thanks.
Carry on.
Yeah, Varun, please start. You have 12 minutes.
Hello, Varun. Please start your presentation.
Just a minute. I'm having some problem. Just a minute. Hello? Hello? Could you
Yes.
please, could you please make Rishikesh present the screen, please? I'm having some problem. That's why I'm not able.
No,
Rishikesh MP.
your screen just came, right?
Yes, yes, but I'm having some problem. He has a slide. My screen is not that responsible.
Okay.
So there is another person, yeah, Rishikesh.
Who's the next person? Himanshu, are you ready?
No, Rajiv, there is the other author, Rishikesh, who is ready to present, is what he said.
Yes, yes.
Okay, we can move to Rishikesh then. In that case, where is Rishikesh?
Hello, am I audible?
Hi,
Yes,
Rishikesh.
yes, you're on.
Yeah,
Yeah,
I made
actually,
you.
there was a misunderstanding. I was going to present, but you called him, so he, I think,
No
just
issue.
panicked.
No, no, it's okay. So, Rishikesh, yeah, can you share your screen now?
Yeah, yeah, yeah. One minute.
Okay, no issue.
Can you see my screen?
I guess it's starting to share content.
Can you see my screen?
Yeah, at least I cannot see it. It's
Just
saying,
let me know when you can see the
Yes,
screen. I'll start.
yes, it's visible now.
yeah,
Shall I start?
yeah, yeah.
Good afternoon to all. Herewith, I am presenting a work titled Development and Evaluation of an AI System for Early Detection of COVID-19 Pneumonia using Excel, co-authored by my colleagues Mohit Mishra, Varun Parashar, and myself, Rishikesh. We are currently undergraduate students from IIIT Guwahati. During the course of this presentation, I would go through the following topics which would highlight the problem and the novel features of the AI system. Basically, in the approach, we would discuss our proposed architecture, the evaluation metrics that it would be benchmarked upon, and the challenges, issues that we faced while developing our architecture. The COVID-19 pandemic has already spread all across the world, and the early detection of the novel coronavirus would help in triaging and successful treatment of infected people. Thus, our work below aims at integrating AI with medical science to develop a classification tool to recognize COVID-19 infection and other lung ailments. The images for training were collected retrospectively and analyzed. X-ray images of COVID-19 positive patients along with pneumonic patients were used to train and validate a classification framework using the CNNs. During the course of the work, we also attempt to present a case for a novel CNN architecture inspired by state-of-the-art convolutional blocks. So the core part of the Cove AINet architecture, as we call it, are basically CNNs, typical CNNs, particularly state-of-the-art convolutional blocks inspired from Inception architecture, the DenseNet, and the Exception. The input X-rays were pre-processed, and due to the limited X-ray images at the time, various augmentation techniques too were applied. Discussing about the architecture now, the overall architecture itself is divided into three parts, namely the entry flow, the middle flow, and the exit flow. The entry flow facilitates as the initial part of the architecture which accepts the X-ray volumes. The entry flow, as you can see here, has two inception blocks to allow for more efficient computation and deeper networks through a dimensionality reduction with stacked convolutions. These modules were designed to solve the problem of computational expense and overfitting, among other issues. The solution, in short, is to take multiple kernel size filters, as you can see here, within the CNN, and rather than stacking them up sequentially, we order them to operate on the of the architecture, that is the middle flow, consists of two connected blocks, as you can see, the dense block and the transition blocks. The number of block connected layers in the middle flow are given in the table. The middle usually consists of 4 connected layers. DenseNet has been one of the state-of-the-art neural networks for visual object recognition. For each layer, the feature maps of all preceding layers are used as inputs, and its own feature map are used as input in all the other subsequent layers. The advantage gained by using DenseNet blocks was to alleviate the vanishing gradient problem, strengthen our feature proposition, encourage the feature reuse, and substantially reduce the number of parameters. The last part of the architecture, the exit flow, classifies the feature volumes from the middle flow into the required output. In this case, it would be pneumonic and non-pneumonic, and COVID positive and COVID negative. As we know, the COVID negative is a form of a pneumonia. Coming to the classification model, you can see here the schematic diagram of our overall architecture. So as a whole, the entry flow, middle flow, and exit flow facilitate feature extraction, feature processing, and the producing the output respectively. Therefore, the architecture as a whole has been inspired by state-of-the-art convolutional blocks for inception, DenseNet, and exception by combining appropriate features from the node, ensuring smooth gradient flow and fast convolutions. If we look at the whole Cove AI system, which consists of the Cove AINet architecture, here it has been divided into 2 stages, stage 1 and stage 2. The stage 1 consists of feeding the X-ray samples into the architecture and classifying it as mnemonic and non-mnemonic. And the mnemonic classification further is fed to the architecture again to classify it as COVID positive and COVID negative. Various evaluation metrics like accuracy, specificity, sensitivity, precision, F1 score, PPV and NPV scores were used to evaluate the architecture. The binary classification was done here. A 2-stage classification was done here to ensure better accuracy for predicting COVID-19 pneumonia and increasing accuracy on the limited data set. The accuracy here can be seen as 96.5 for stage 1 and 98.31% for stage 2. The challenges or the issues that we faced during the course of the work were mostly due to the extremely limited dataset that was available at the time. Augmentation techniques were useful, but only to a certain extent, as due to reduced number of image samples of each class. We also understand that for this currently limited dataset, The architecture might have some redundant layers only for this dataset, but we also believe that the full capability of the architecture might be visible on a larger dataset, which is included in our future work. Further, the architecture can be optimized as more suitable hyperparameters may be identified. The motivation of this study was to utilize artificial intelligence to solve the problem of shortage of interpretation of X-ray images in this fast-spreading pandemic. The study facilitates the goal of mass testing of population. By doing so, we aim to take inspiration from 3 state-of-the-art architectures and combine their useful convolutional blocks to develop the architecture. The work thus basically provides high precision, invasive diagnostic system for screening and identification of COVID-19 disease using AI and medical science. The future work for the COVE AI system would be to primarily train it on a large dataset and also to train it using CT scans to classify them as COVID positive or COVID negative. Lastly, for the COVE AINet architecture individually, we aim to optimize it further and also benchmark it on high quality datasets. Thank you. If you have any questions.
Thank you, Rushikesh. So any
Hello. Can you introduce a little bit about the data sets? What's the challenge issues you have already solved?
Actually, the problem was we at the time that we started this study, there was a very limited data set. About I think about 1800 images, out of which 300 to 400 images were COVID positive, others were pneumonic and non-pneumonic. So augmentation techniques, using the help of augmentation techniques by rotating it left and right and cropping it, we made it to somehow 15,000 images and trained it on them.
Okay.
Okay, I would like to ask one question. Rushikesh, do you cite any medical rationale behind looking for COVID in X-ray images?
I'm sorry, I'm not getting what you are actually asking.
Means in your slide
existing
or
study.
yeah, in your slide or in your paper, have you cited any medical rationale, a journal or a book or something from medicine which claims that looking at X-ray, a doctor can actually determine whether it is.
Yes. We have actually cited a radiology society from I think Italy or something, which confirms that COVID can be spotted from X-rays. Actually, the problem is from the X-rays we can classify it as pneumonia, and pneumonia can be classified from the X-rays, and we are further classifying it as COVID positive or COVID negative.
Okay, means there is a medical rationale behind.
Yeah.
Okay, fine.
So Rishikesh, yeah. So as you know, I mean, as you mentioned, like from the images, you first diagnose whether it's a pneumonia or not, right? And if it is pneumonia, then it might be COVID or not, right?
Yeah.
So in how many such cases? I mean, when the person has pneumonia but not COVID, I mean, what is the false positive? Result for your case.
Yeah. So actually, in our training data set, I would speak of. In where we had 1800 images, 300 were COVID positive, about 400 to 500 were pneumonic but not COVID positive, and the others were non-pneumonic, normal.
Okay, so the last question is, I mean, why do you think? I mean, why do people don't use this? I mean, if the X-ray is the best way of finding the COVID situation, but why people not going? I mean, if you see in India, I mean, how many people go for X-ray to check COVID, or even anywhere in the world?
Yeah. So actually, this study we initially aimed as a complementary for the RT-PCR tests that are going nowadays. Actually, RT-PCR tests may be more accurate, but they are slow. We are just finding this study to speed up the RT-PCR processes. Like if there is something called pool mass testing, where you can repeatedly get the X-ray images, and only you will have to apply the RT-PCR only on some of the people if we pool the mass testing and then classify it from there. So actually, it was just a complement to the RT-PCR tests.
Okay. Yeah. So Deepak, I'm done. If you have any questions.
No, so let's thank you then, Rishikesh.
Yeah, thank you.
We can move on. It's already 4:30. So,
Thank
do we have Himanshu now?
Probably Himanshu can go in the last. I think
Okay.
two people are
Okay,
waiting.
then
I can leave from
Sahana.
the
then
previous slide.
let's
Yeah.
Sahana. Yeah.
So let me Sahana and Sandhya. Okay. Sahana, will you be sharing the screen? Okay.
So I'm loud and clear, right?
Yeah, we can hear you.
Yes.
Okay.
I made you presenter. I will also add Sandhya as a panelist so that she can also speak, right?
Yes. Yeah. Thanks. Yeah.
Okay, Sahana, please start.
Yes. Okay. So it's visible. My screen is visible, no? Just confirming.
Yes. Please go ahead.
Okay. So good evening, everyone. This is Sahana and my teammate Sandhya. We'll be presenting the paper towards a safer conversation space, detection of toxic content. My other panelists, Tanuja, Sushma, Jina, there in the audience as well. This is submission number 115. So yeah, quickly talking about agenda, we'll be covering the problem statement, data collection, pre-processing, the models we have used, namely NBSVM, the XGBoost and deep learning models, and then assemble to combine all the classifiers. We'll see the conclusion and the future work as well. So quickly diving into the problem statement, right? So talking about toxicity. So how can we define it? So in very generic way, we can say it's a rude and a disrespectful way that makes a person leave a discussion. But if we think about how this toxicity is dealt in social media, it's mostly dealt in hindsight. So there's some toxic content and there's a user who feels it's against his values or anything, and it's going to be flagged. The company is going to, it's left to the discretion of the company to take it out. So the future is towards the real-time detection of toxicity, right? So you're not letting the user put that content on the social media in the first place. So that was our main motivation, because it's not really used in any mainstream social media. So talking about the data set, we have used a combination of two data sets. One is the really famous Davidson's data set, wherein there were three classes: hate, non-hate, and offensive. So for the purpose of our task, since it's a binary classification task, we combine the offensive and hate as toxic and the non-hate as non-toxic. In order to make the class balance equal, we combined it with another open source data set that had hate and non-hate. So by this, we were able to get like a 50K corpus, which we used for the purpose of training and testing. So since we mainly deal with tweets here, tweets, as we know, is extremely noisy, right? So processing is really important. So other than the normal pre-processing that we can think of in the Twitter, like replacing the slangs, HTML tags, URLs, etc., we also replace the elongated text. Like you can see, like happy is being replaced to happy. So we know that there's no word in English, right, that has 3 consecutive letters. So by doing this, we were even able to correct most of the spellings as well. So this is just one of the precautions we took. Talking about feature engineering, since we used machine learning models as well, we use this n-gram features weight by TF-IDF scores and stack together along with the POS tags. And the statistical features, well, there are a lot of statistical features, right? So in order to choose the top statistical features, which really is of importance, we used random forest to get the feature importance score. So all these were stacked together to give the features for our machine learning models. So yeah, we really wanted a pretty strong baseline to start with. So NBSVM has been used as a good baseline for many NLP tasks, right? And especially in our tasks, since we are dealing with tweets, and if we see the statistics, 95% of the tweets are less than 140 characters, which means toxicity in Twitter can be exhibited in as less as a word to 2 words. So our model had to be very robust to the length of the input. So we think the NBSVM performed really well. Talking about that, of course, the accuracy we were able to get with the NBSVM was pretty good, around 93%. But however, the paper that really proposed NBSVM that told we could use logistic regression in place of SVM, it would give similar results. We had actually used LR as our base ML model, but we know that LR really has a high bias, right? So in order to counteract with that, we used a decision tree based ensemble, that's XGBoost, so that we can generalize better. So these two models are really, really diverse, which gives us a reason to combine. So both of them gave a pretty good accuracy of 93 to start with. But we know that there's only so much we can go with the classic machine learning models, right? So though they're really good to classify the comments when they're in far apart from the decision boundary, when there is very subtle toxicity, we really need to understand the nuances of the training data. And that can be really done only with deep learning. Keeping that in mind, we started with CNN. So we used a really popular architecture of CNN for our task. So we used CNN of 3 filter sizes, 3 for 5 namely, and each of it producing 10 feature maps. Of course, we used the global max pooling and a soft max activation to give the output. But CNN comes with its own drawbacks, right? So we used further deep learning models in order to counteract with these drawbacks. So I would like my friend to take over.
Okay, next. So yeah, in CNN, most we can do is take only 5 words at once and try to get the context. But what really happens is in Twitter, like the last sentence could be dependent on first sentence. So we need this there's a long-term dependency, so which you really can't find in CNN. And that's why we wanted to try out RNN models. So in RNN model, like we know it has like the version we use by GRU, which is one of the version of RNN, and it captures the long-term dependencies. And also, in order to get the context of a word, you're not just depending on one side of it. It's bi-directional, so you get better context of why the word is used there. And in order to avoid the overfitting problem, we also use max pooling, and then we use dropout layer. And then the dense layer in order to find the probability, we use softmax there. And next slide. So yeah, now when it comes to these models like CNN and RNN, like they're more like count vectors if you want to relate it to machine learning. But like we use TF, ITF because it gives importance of every word. But these models, like they considered all words to be of equal importance. So that's why we tried out attention, because we wanted something like TF, ITF in deep learning models. So in this, like you can see that ramen was delicious, like especially in Twitter, like there are a lot of stop words, like, and then like if you want to combine all of that, the classification won't be good because there are a lot of stop words. So that's why we wanted to try out attention. And so basically what this attention model did was it had this context vector. And then so this context vector, it trained that context vector in order to assign importance code to word in the sentence. So yeah, and then this attention model gave us better accuracy than the other deep learning models we used. And then like even this attention model was not interpretable. Like if there was a reason, okay, even if you give the sentence to the attention model, like you couldn't really say, okay, what was happening? Usually most deep learning models are kind of black box. So we wanted to understand the context better. So we thought if we could combine it with deep learning models and these, maybe we could get a better score. So we did the correlation analysis between these models, and these models were pretty diverse. And so we put it in an ensemble, and our results show that the ensemble model performed better, and we got like highest FN score. So yeah, now we do have other I mean, this problem is really popular. Like everybody is working on it. So, but the most of the work we looked into, like they were looking for specific words. Okay, if the sentence has this specific word, they usually flag it as it's hate. You can't tweet it, something like that. Maybe when it comes to but when it comes to Twitter, these words are pretty common. Like you can't really flag them as toxic just because of the presence of those words. So that's what we try to solve. And then we wanted to filter out those comments which is against certain community or something like that. And we were pretty okay with the profanity considering it's Twitter, and then considering the age group, age demographic that is on Twitter. So yeah, like you can see the first sentence here, this sentence doesn't really have any of those words, but you still don't want people to tweet something like this because this is not right, and this could hurt many. So
can you try to wrap up soon? It's 12 minutes, going to be 12 minutes.
Yeah. So these are the two examples we tried, and we also tried one with those words. And then, for example, this thing, and our model considered it as non-toxic. And then a model does have shortcomings. Yeah. So you can see that other one. So and what is the observation here was. Deep learning, machine learning models, they perform really well for non-toxic data. They didn't do really well for toxic data. But our deep learning models did the opposite. They performed well for toxic data, but they didn't do really well for non-toxic data. So when we combined all of these, we got the best of both worlds, and that was one of our observation. And next slide, please. So yeah, future work include we there are a lot of other challenges so we try to include the historic data as well, because in Twitter the threads are pretty common. So in order to get the context of one tweet, it's better if you know the following tweets or what are the tweets occurred before. And we also try to use language models, and we'll also try to look into network attributes, looking at the pages they follow. Can you predict something? Thank you. So any questions?
Okay. Thank you, Sandhya and Sahana. Any questions?
Hello. Can you introduce and explain what kind of challenging issues you have solved in your model?
Yeah, sure. So you can see, like we said, usually if it has any any filter words, if they're what few models do is they look for certain words and they flag it, even though that's not in a negative sense, even though that's not meant in a negative sense. So our model didn't do that. You could see in the last example. Can you go back 2 slides?
Well,
yeah. Can you go back? So you can see here, look at this example. Usually they look for the presence of these words and they flag it. And other challenges were, some few words, they don't contain any of those words at all. But you need to understand what it means in order to classify it as toxic. The first word doesn't have anything like that. And even when it comes to racial slurs, the models don't really understand that. And our model could solve that too, to a certain extent. But yeah, again, you can see in this example, for this, our model didn't do that well. So yeah, these two are the challenges that our model could solve.
Okay.
Thank you.
Yeah, thank you.
thank you.
Is there any other question?
So yeah, probably I have one more question. So so the T. Davidson dataset that you're referring, that is only mainly for the US context, right? So if you have to basically build something, probably some model for Indian context, or probably and not US context, I mean, what all steps you have to do?
Yeah, that's right.
Yeah.
So we included that in our future work. Like, yeah, when it comes to India, it's really hard because, people tend to use the regional language as well. So that is one of the challenges. So we included that as a part of future work.
Second thing, probably I missed. Do you have any quantitative result to show? I don't know if I missed it.
Oh, yeah, right. But I think we don't include it.
Yeah, we didn't include it in the slide like the result tables.
So what was that? I mean, which evaluation metric did you use and how was it?
So basically, at the beginning, we tried to use only F1 score. But then after that, we used everything else. We used precision, we used recall, we used F1, and accuracy was also used because since the distributions of our classes are pretty comparable, like it's not, it's not skewed to one side. So yeah, we mentioned accuracy as well. But Ensemble performed well on all of those metrics compared to other models.
No, how accurate was that?
So the accuracy was 95.3.
Okay.
Yeah, that was the highest we could get from the ensemble model. Yeah.
So, and then, so our precision was 97 for toxic data and 96 for non-toxic. And recall is 97 and 95.
Okay, I guess, thanks. So who will be the next presenter? Can you message in the chat box?
Thank you.
Who is ready to present or raise your hand?
So either Kritika, Aman Goyal or Aman Saini, one of these.
Aman Goyal, okay. Aman Goyal, can you hear us? Aman?
Hello.
Yeah, Aman, would you like to present?
Yeah, so Kritika would be presenting actually.
Kritika, okay. Yeah.
Hello. Can you please give me the permission to?
Yes, Kritika, you have. Check it now.
Okay. Yeah, thank you.
Okay, so you have 12 minutes. Please start.
Just give me a second. Can you see the presentation if you can confirm?
Yes, we can see. Thanks.
Okay. Thank you. So good evening, everyone. I'm Kritika, and along with my team, we have worked on this great project called Multimodal Emotion Recognition in Polish. So me, along with, we did this during our internship at Leading India AI last year. So me, Aman Goyal, Aman Saini, Akshay, with our advisor, Dr. Sridhar Swaminathan from Bennett University. So talking about the presentation outline, we are going to discuss the background and purpose of our research, the three modalities that we are integrating, and how we are integrating them, some experimental results, the challenges that we faced during this research, and the conclusions. So talking about the background and purpose. So when we talk about emotions, we usually directly link it with our facial expressions. But there have been several researchers that have shown that the emotion that you reflect is a combination of when you combine different sides of your body. So it's a combination of your gestures, your body gestures, your facial expression, and even the sound of your voice. So what you're speaking and the intonations that you're using, etc. When you combine all of these things, that is going to convey emotion in the true sense of the term. So with this research, we are trying to address the existing challenge on multimodal emotion recognition by artificial agents such as robotic systems to understand human emotional states using different modalities. Now, the data set that we have used in this paper is a fairly recent data set called the Polish data set for emotions. So this data set, it has been created under a studio circumstances where they brought an equal number of male and female actors who are enacting out the different 6 emotions, and we have used that data set consistently. So going into the 3 modalities that we have used, the first one is the body gestures. So for this, we used Kinect capture data, which is containing the XYZ coordinates of the different the 25 joints of our body, and also their angles of rotation. So this has been used for detecting the body landmarks given in the video samples. Then the data set that we had, the total number of videos present there were very less. So we had 63 videos if we combine the male and female actors. And in each of these videos, there were 5 different instances where that said emotion was being displayed properly. So we had around 315 different samples which we used for training. So the data set that we had, it was very less. So we used data augmentation. So we used horizontal flipping of all these landmark coordinates to avoid overfitting in the gestures. Then we extensively experimented with selection model hyperparameters and selecting them. Finally, for classification, since the videos that were there, they were of a different lengths. So we used an LSTM model for classification in one of the 7 Ekman's emotion categories. Now, talking about the facial expression. So for facial expression, we firstly extracted the videos into frames. Then for each frame, we detected the 68 facial landmarks that are present in our face. Now, the positions of the actors with respect to the camera, they were changing continuously. So what we did is we calculated the Euclidean distance between all these 60 facial landmarks to minimize the effect of axis and position of the actors. So what we, in the end, we got this undirected graph, which was denoting the facial expression. Finally, we added another feature for gender by combining it with the facial expression matrix and used an LSTM model for classification again. Now, one of the main challenges that we encountered during this was that there was a lot of blurriness because of motion. So we couldn't properly extract some frames in the from the videos. So there were a lot of empty frames. There was a lot of commotion, and the body movement and motion blur was present. So we had to remove all such frames where we couldn't detect the face of that person, and that was a challenge that we faced. Now, talking about this page, so we had, for every video, we had 5 different segments which were portraying the said emotion. So the audio files of WAV format, they were extracted from the videos and then segmented into multiple files. For feature extraction, we used the MFCC coefficient, and it was normalized for each of these data points. An LSTM network was used to train the model again. Now, in speech, again, we faced the challenge that the dataset size was very limited, and it was leading to overfitting the model initially. Now, how did we integrate the various modalities? So for each of the body language, facial expression, and moved towards classification using an LSTM model, received the output, and then we used multimodal fusion using the weighted average technique to get the final said emotion. These are the experimental results. So we the baseline that we have taken for comparison is using a convolutional neural network. And you can see that the accuracy is like about 72%. Then we have computed the individual training and testing accuracies for each of the 3 modalities that we have used. So here you can see the results that body language and gestures is providing us with an accuracy of 62%. Facial expressions is providing us with a testing accuracy of 71%. And speech has been providing less accuracy because of the less number of samples, so only 61%. But the fusion results, they are showing us better results when we combine them with an accuracy of 74.6%. So the comparison says it all, that when you combine multiple modalities, the fusion performs fairly better than the individual ones. So talking about the challenges, so as I said earlier, that the data set, it has been recorded in a studio setting. So when you try to test it in real-time conditions or YouTube clips, etc., so the model fails to perform well. For the body gestures modules to perform accurately, a hardware device of the Kinect device is required. The total number of samples in the data set, they were 2 less, and we augmented the data using flipping and all these things, but it was still leading to overfitting. The availability of data sets, which combines all these 3 modalities right now is very less. So this polished data set that we have used in our research, it's the biggest data set so far, and we hope that much more data sets come up and we can incorporate our technique and test them out on those. So distortions, motion blur, etc., they have been a challenge for us to deal with. So we want to, in the future work, we want to devise a technique which can tackle such distortions while capturing videos and still maintaining the performance of the model, basically making it much more robust than it is currently. Finally, right now we have used speech, but we are not considering the choice that the speech, the words that that person is using, are they also going to have an impact on the emotion by the person? So we plan to incorporate more modalities in the system to enhance performance. So talking about the conclusions, what we are proposing is an end-to-end multimodal system which uses neural network architectures, especially the 3 modalities: body gestures, facial expressions, and speech. For each of these, we have used Kinect capture data for gestures, facial landmark detection for facial expressions, and MFCC for speech to pre-process the data. We have used 3 different LSTM networks to predict the emotion in each of the modalities and then use the weighted average of the outputs to get the final emotion. So that's the work that we have done so far. Thank you so much. I'm open to answer any questions.
Thank you, Kritika. Any questions? Rajiv, you?
Yeah, Kritika. Hi, I'm Dr. Dinesh. Kritika, I have seen your paper, and where I have seen that you are talking about 3 modalities. And
Yes,
so in these out of modalities, body language and facial expression, how you are trying to say that these are 2 different modalities and that are coming from 2 different modes of a sensor that data you are collecting?
So, sir, when in the data set, when the actors are moving, there are a lot of instances where the face of that actor...
One thing, face and body. So you are trying to say that face is a separate thing from body?
No, sir. But what I'm talking about is that when you're talking about body gestures, face is just one component. So we are contemplating 25 joints.
Katika, but you try to derive in your paper that is are different modalities. That is from one mode. So you are using separate kind of camera to capture your faces, and the body you are trying to have a separate kind of camera.
Yes, sir.
From the same data, you are trying to eliminate these things.
Yes, sir. For body language, we are using the Kinect capture device. So that is providing us with the coordinates of the 25 joints of the body. But for facial expression, we have for facial expression, we are using the video camera, then using facial landmark detection to get the coordinates of the 68 facial landmarks.
Okay,
that's what we are doing.
Okay, this is fine. But now next is why you are using LSTM?
Why we are using LSTM?
Yeah, is there any specific reason to use LSTM over here?
Yes, sir. So firstly, we tried using the CNN model, but the issue was that the videos, they were of different lengths. Some of the videos, they were very short in duration, like limiting to 2 seconds, but some of the instances, they were ranging between like 10 to 15 seconds. So to normalize their effect, we were using the LSTM network.
Okay, thank you, Kritika. Thank you. Very nice.
Hello. Compared with the existing work, what kind of solution you have done to improve the accuracy?
Sorry, can you please repeat?
Okay. Comparing with existing work, what kind of technology you have done, which can be used to improve the accuracy?
Okay, so to improve the accuracy, mainly I'm suggesting two ways. First is we need a bigger data set that consists of more videos. Another thing that is very crucial here is that we need to incorporate more modalities. For example, in the data set, all the actors that are speaking, they are speaking the same sentence. But if you want to make the model more robust, we also need to take into account the sentence that they are speaking, because sentence conveys a separate emotion as well. So if we try to combine these four things, I think the model will perform a lot better.
Okay, thank you.
Okay, thank you, Kritika. Let's move on to the next presentation. That is crowd-flow collision simulation. So who is representing that paper here?
Any authors? I think Tariq is here. Okay. Hey Tariq, I made you one of the panelists. Let me share the presentation, right? Okay, so you have the presentation privilege as well now. So please share your screen and get started.
Hello.
Hey Tariq.
Yeah.
Yeah. Please start with your presentation. Hey Tariq,
Rajiv,
what is the
looks
issue?
like
You have the slides. Tariq, can you hear us? Your slide is there, right? What is the issue?
yeah, we can see your screens.
Hey Tariq, can you hear us? Hello? Tariq? I don't know how to get the main screen to voice. Can you okay, can you speak something?
Hello, can you hear
Yeah.
me?
Yeah. So just
Can you hear me now?
Yeah, I can hear you. Can you just
Okay, good.
show the slide that you have?
Sure, sure.
If you see on the top left, there is a button. You need to click it. Yeah, just between the draw and design.
Okay. Can you hear me now?
Yeah.
Okay.
Yes,
my name
please
is
go
Tariq
ahead.
Kalafif.
Yeah, please.
My name is Tariq Kalafif. Sorry for this issue. I thought that the voice is not working. I'm presenting my undergraduate students project on crowd flow collision simulation. next. Okay, before we get to the work have done by the students, I want to show you some definitions. Crowd, we can define crowd as a collection of small groups of people. Simulation is also can be defined as the process of imitating, which we imitate real thing or circumstance and practical process. Crowd collision can be defined as two or more groups collide in different ways, different directions, which may result in body injuries. Too many simulations have been done using Unity. In this research work, my students use Unity platform to simulate the complex and varied content of crowd scenarios. The study of the crowd scenes has become an interesting research area in simulation and computer vision. And there was a problem for crowd flow collision, especially if we have many people, let's say 100,000 or probably millions of people in one spot, since it may cause death or injuries. Then we looked at, my student looked at the previous research works. They see that crowd flow collisions are only confined in 1D and 2D directions. So they proposed a 3D simulation for crowd flow collisions in different directions, and they use different types of agents in this simulation. This is an example of the agents they have used in the simulation, different agents where they have different walk-in speeds and different actions. The first case they simulate is the intersection case where two groups of people, they collide an intersection case. You can see in figure 8 is the before collision. The figure 9 is during the collision. A flag is raised when any collisions happens between these two groups. Another case is a two-way collisions where two groups opposing each other. You can see in figure 6 these two small groups, but still this is a small scale crowd. It's not a large scale, but still there is a collision between them. You can see it in figure 7. In another scenario, another case is the heterogeneous, where collisions can occur between or within the crowd. You can see we have spotted on the red circle. For the efficiency, basically the speed gets slower when more agents are added. I think that if we have to build a simulation for large scale crowd, we need a dedicated resources, such as a very dedicated GPU. So we conclude this talk by this work. They simulated crowd flow collisions in different directions. They consider crowd entry and exit from gates as a case study, and they run the simulation in their computers. They observe that the frames are dropped below 35 when the agents are more than 100. That's all. Sorry, my students are not attending this, but if you have any questions, you can ask.
Hello, thank you for the presentation. Okay, I have one question. Is the main motivation of this work the lack of unity simulation, not being able to simulate crowd flows efficiently? Is that the main motivation?
No, basically we are trying to motivate the body injuries that occurred from the collisions of crowds, since we have the Hajj and Umrah, we're trying to study these kind of collisions cases, of course, in simulation, and then maybe later we will implement it in a large scale.
No, so the reason I ask is I don't recollect the paper, but I don't see any. So what was the? Can you go back to the graph that you had? Yeah, I don't see any result on a data set with the kind of injuries that you catch or the kind of collisions that you catch.
Oh, we and the simulation we just yeah, this result is in the paper, but we haven't used it's a simulation. So basically my students did programmed a flag whenever there is a collision. In these cases, flag is raised. So we are trying to simulate real life situations of collisions between the crowd. So maybe later we will extend this to a large scale where too many people in one spot. These are not considered, the distance is just 100, but they have seen that the performance of the GPU where they have, it's a naive GPU, it's dropped, every time they add any more agent.
Okay. Any other question?
Yes, hi Tariq. Here in the PPT, you have written a simulation efficiency. While in the curve with this graph, we can't see where is the efficiency in this one.
I don't understand your question. You said
in figure 11, in this figure which you are showing, the graph which you are showing, in this graph you have written simulation efficiency. How we can understand this is a simulation efficiency? Because one side you are writing frame per second, another side you are writing agents, but on the top you are writing simulation efficiency. So if it so how we can understand the simulation efficiency?
Yeah, basically the agents. The more we add agents to this simulation, it gets lower in the frame per second. So you can see it gets, I think, 34 when it's 100 agent. So that's what they have done in their experiment.
But generally, Tariq, that comes efficiency in terms of percentage, in terms of means accuracy that you, but here it was a confusion for me. Okay, thank you very much.
Okay.
So do we have any other question? Okay, looks like there is no other question. So thank you, Tariq. So we have one presentation left, which is by Himanshu.
Yeah, so we have the last presentation. So he has issue in sharing the screen. So I'm sharing.
Yes, Dr. Rajiv. Dr. Rajiv, can you hear me?
Dr. Viskarma, I can hear you, please.
Dr. Rajiv, there is a feedback for Tariq. Tariq, you can check out your referencing style, which is not in IEEE. So please, you can check out. The paper which you submitted, it is not in IEEE format, the referencing style.
Excuse me?
Yes, Tariq, can you hear me?
Rajiv, how many papers the students were Well, I think we have already done. Not yet.
No, this is the last one.
Okay.
So Himanshu, you have 10 minutes, so you need to rush up. Okay.
Yeah, good afternoon all. Sorry for the inconvenience caused. I will quickly complete this presentation. So my name is Himanshu Singh. I, under the guidance of Professor Rajiv Ratan Shah, designed and developed a venue booking system. And we took a use case of triple IT, for which we named it book triple IT. So it's basically book it. Now there are four contents of this presentation. We will go quickly through one by one. First, abstract. So next slide. Yeah, every institution has its own system of booking spaces. Now mostly it is done through mail system. So what's the need of this new venue booking system? The need arises from the challenges like absence of knowledge of available spaces, tediousness, improper management of bookings, clashes in bookings, communication failures, and etc. These indicated a need for a well-defined, efficient, visualizable, and a user-friendly space management system. So in this paper, a Flutter app was proposed, which was designed using design thinking and packed framework to make it user-friendly and efficient. I'll quickly go through the methodology part. Basically, I used design thinking and hybrid of agile waterfall development model. So there was first phase of understanding phase, in which I identified stakeholders, designed a problem statement, held surveys and interviews, and did packed analysis to better understand the situation. Now, second phase was exploring, in which I did literature review. I did platform exploration, in which language, in which framework to code the solution, and brainstorming. The third was prototype phase, in which a feature prioritization, sitemap, low fidelity prototype, etc. was done. And the fourth was evaluation phase, continuous feedback, usability testing, and Nielsen heuristics were used to evaluate the prototype developed. Moving on. So I wanted to show you the application, but I can't. So I'll quickly go through the slides. So this is the login screen. This is the first screen which you will see after entering the URL. In with this, as it is developed for triple IT, only triple IT email IDs and certain email IDs allowed by administration will be entered in this application. So you log in through triple IT email ID. Then there's the home screen. On home screen, you see all the buildings that are available for booking. And you can also search for a space in the search bar. Now the important part is, in an institution, different departments might not communicate with each other about the booking of spaces, so they might be handled separately. So in this case, library building and sports block, the department said that they want the booking to be done directly by the users, while the rest has to be done by the user but approved by the administration. So there is a different flow of control for each building. So this is one of the plus point of this model. So next slide. When we click on a building, you can see all the spaces are on the top. Then there is this card in which you enter the details like from when to till when, the date. You can choose a date, you write the description, the reason for your booking, or you can choose the reason, and you add a reminder if you want one, and then you directly book it. This is for library and sports blocks, so the user can book directly. And here are all the time slots. So these are color coded because red one shows that they are already booked. If you click on it, you can see what's the reason of the booking, why is it booked. Uh, can we move on, sir? Yeah, this one is for the other three old academic seminar block, the ones that are controlled by the administration. So this also has a feature of making it an event. So most of the events in the institution are held in these academic spaces like lecture halls, seminar halls, etc. So you can also make your booking an event, which will be shown in the event tab, so that everyone can see. So here you can add event title and all the details. So after you have done the booking, you can also manage your bookings. So you can see here all the stats are provided. That you have 2 approved bookings, 0 pending bookings, 3 you have cancelled, 0 rejected, and 13 previous bookings. So you can also cancel your approved bookings if you think that you are not attending it. So this segregation is also done in manager bookings. As you can see, the segregation is that there is also a icon which you can see on a calendar view. If you click on it, there will be a calendar view, which you will be seeing in the further slides. Next slide, sir. So there's an event screen, as I was telling, that you can make a booking event. So on this event screen, anyone using this app can see the events that are posted here. So you get all the details on a quick view here, and if you want to know more about it, you can just click view more. So here's the calendar view I was talking about. You can search for date by date and you will get all the details. Then there's an admin screen. Now admin has most of the functionalities. It's all the functionalities are provided in this platform. Like recent request will be shown for approval or denial. Previous requests are there. You can download a CSV file or delete it. Feedbacks are there. Admin can clear the time slots. Admin can upload CSVs. CSVs are the data files that are used in this system. Next slide, sir. Then admin can do bulk booking. There are certain situations in which you want to do a bulk booking. So admin has the power to do this. And then there are reset dates. In this, the slots are created. Like there are slots available to October. If a person wants, if the admin wants to create more slots, it can create after October, November, December. So this power is given to admin. And there are some more functionalities that are provided to admin. So these were all elicited from the stakeholders only. Then there is an analytics screen. Now you are getting all this data. So we wanted to analyze it to know which space is being used the most, which space is being used the least, and when it is being used. So you can perform a space-wise analysis, or you can perform a building-wise analysis of each space. You can choose the date. So all the features are provided in this platform. So you can also download a report for your analysis. And there's a pie chart for better graphical representation. And there are some other functionalities like feedback boxes there. And there are different contexts in which you can send a feedback. So there is general feedback, urgent slot creation, etc. This feedback is sent to the admin. So this is to improve the platform for better communication between the user and the admin. There's theme change feature. There is FAQs, how to use about and logout option. So in conclusion, I would like to say we proposed a venue booking system which allows booking of the slot for a venue across an institute ubiquitously. The system handles the synchronous and real-time bookings. It takes care of the problem of multiple bookings by a single user and group bookings for high-capacity venues. It works well in academic institution context, easing out the task of handling booking through various channels. The central system caters to all the stakeholders, and some modifications can be provided to the features for some stakeholders for better departmental functionality or some other reason, as we saw for library and sports complex. So our booking system is well suited for the university as well as schools, where it could ease out the task of handling academic spaces as well as sports complexes. Now, the future work that is there is we will be using GPS technology or QR code scanning, with changing QR codes every day to ensure that the user is using the book space at the chosen slot. So this is the attendance aspect of the system, whether the user who has booked the space is actually using it or not. Identification through face recognition using CCTV camera is also a viable option for this purpose, because we have in this institution in IIIT multiple CCTV cameras. So this can also be done. Option of uploading pictures and videos related to the feedback can be provided to make it richer. So a user can upload videos or pictures. These feedbacks then be mapped to the spaces if they are related to them. So as it is done in Google. So thank you all. I hope you enjoyed it. I'm open to any questions.
So thanks, Himanshu, for
Thank you.
helping us by quickly covering it. Yeah, so probably we can have room for only one question.
Sure, sir.
Do you have any demo to show?
Actually, I have a working site for this, but I cannot present my screen, so that's the problem. That's why I added all the snapshots. I wanted to show you the whole site.
Okay. So what
I
kind
apologize
of
for this.
technology you you used for this system?
I beg your pardon?
What kind of the key technology? Where is the novelty of this technology?
The novelty aspect is the segregation that is provided for different departments in the academic institution. Such type of system, when I was doing the literature review, I didn't see it in the literature review for academic institutions.
Okay, thank you.
Okay, thanks
Thank you.
everyone. So yeah, thanks everyone. So all of
Yeah,
you
thank
are
you.
most welcome to join the town hall meeting. Yeah, so the links are you already have. So you can also follow our Facebook or probably social media pages where we have also posted the links there. So please join the town hall meeting. We will be stopping here. Many thanks everyone. Thanks Dr. Yu, Dr. Visukarma and Dr. Gangadharan for helping out.
Okay, thank you. Thank you so much.
Thank you.
Thanks.
Bye.
Thanks. Okay, bye.
Thank you, Raju.
Thank you.